to assign slab loads in ETABS. As you can see, I am taking the previous model which is made default with the uniform grid spacing. So our first task is to draw the slab of the suitable or required depth in ETABS. So here you can take a preliminary slab depth with the concrete grade based on the requirements of the project. So here I am taking M30 grade concrete. So this is the one way to define the slab as a shell thin modeling type, and I will consider the thickness of the slab as 150 mm. You can see in the type there are different types of slab like drop, stiff, rib, matte, which is used in flat slab as well as at the time of footing. So at the last I will explain the difference between the shell thin and the membrane type of slab in ETABS. So here I will try to define both the type, one as a shell thin and other as a membrane as well. If you see for membrane, the option has pop up like use special one-way load distribution. So it clearly defines means as a two-way and the one-way slab. Now I will give the property name as a membrane. So we have defined these two type of slab and we'll assign this slab to our model separately, where I have considered for one floor I will assign membrane type of slab and for one floor I will give shell type of slab. So when you're assigning the slab, there are some commands like from point to point you can draw the slab. Also, if the panel is rectangular, you can directly use rectangular option to draw the rectangular slab, and there is based on the grids also the slab will be drawn the way which I have used here. Now we'll assign the slab loads which are categorized as dead load and live load, and here the load distribution is uniform. Most type of slab, the direction of load is gravity only. So here, as we have already defined the slab with the required thickness, and in the load pattern you will find that dead load means the self weight of the slab automatic it will going to consider in ETAB, so no need to assign the self weight as separate. So that's why we'll move to the live load. You can see the unit kilonewton per meter square, so we'll take the live load as 2 kilonewton per meter square. After that, select the slab one by one, or you can drag and select all the slab at a time, and you can apply the load by clicking on the apply button, and by right clicking on the slab you can see the load has been applied successfully or not. So I am here applying the load to both of the slab which we have defined, one as membrane and other one as shell thin. For more details about live load you can refer to the course which is made where the information is given for live load for various class of the room size and the room usage according to that. So now I will show you another way to define the slab. Here I will define the slab as a massless property, and here I will give the load of dead means the self weight of slab manually. Here I will make the density of the material as 0, so the property will act as a massless property, where I can define the dead load manually and calculate it as per the requirement. as I have been defined the property, so now I have to define the slab property using massless separately. So here I can take any slab, shell, thin or membrane, where I will add the copy of property and I will just change the slab material as a massless, which we have defined earlier. So here we don't need to think or consider the thickness of the slab. So here we have defined the slab property for massless slab. So now we'll draw this massless property of slab at story 4 with the same procedure as we have drawn the slab for previous properties. So now our slab has been drawn, and you can see that some of the slab property you can see by turning on the labels. So here different properties you can see by for every story we have defined different property of slab. So for massless property we have remained to give the slab loading. So here we'll assign the dead load and live load as well, both. So dead load you can calculate manually by taking the same thickness which we have defined earlier, with the also adding the floor finish or any waterproofing extra load you can add in the manual sulfate and give here. So here I have just defined some value in dead load as 5 kilonewton per meter square, and you can see the value has been assigned successfully. Now I will tell you the difference between the membrane and shell thin type of slab. As you can read here, the beams which are located under the membrane area objects generate higher moments than when under shell area, because load which is applied to membrane object transfer directly to the supporting structural object, whereas mesh shell objects have bending stiffness and therefore resist a portion of the load through flexural deformation. So means if you define the shell thin of slab, it will take the load, and in case of membrane the load will directly transfer to the supporting members, which is beam. Membrane type of slab will not take any of such load, which result in no moment, no shear in slab. In shell thin it will take the moment, shear in slab because of the flexural stiffness is considered. It will also absorb some amount of moment, shear, and then it will transfer to the supporting member. This shell thin type of slab can be auto mesh and realistic in nature, whereas membrane slab are used to support where the moments and shear will transfer directly. So thanks for watching.